Hi everyone, and welcome to this brief introduction to the tool fMRIPrepCleanup. Here I'll give a brief overview of why this tool was created and how it works. As I'll say a couple times, the script does present a risk of accidentally deleting important files if not properly used. We've introduced a couple measures to stop this from happening though, so please do watch through the whole video or read the GitHub README file in full to learn about them before jumping in. Okay, so first a bit of background. If you found this video, you probably know what fMRIPrep is. For those who don't, it's an fMRI pre-processing package that combines best practice tools from a number of different sources. fMRIPrep is great in terms of the fact that it produces well-indexed output that can be flexibly adapted based on the needs of the user. One of the downsides, however, is that it produces a huge number of files, the vast majority of which probably aren't of any interest or use to you. Just using an example of some data I've been working with recently, I found that fMRIPrep produced an average of 5.55 gigabytes of data per subject, and only 4% of this file size was of any use to me in post-pre-processing analysis. Most of this file size is contained within the working directory created by fMRIPrep, what some people call scratch space, but it does also include files in the final output directory as well. The problem here is that keeping a large amount of junk files stored on servers isn't very sustainable. First, the faster servers fill up, the more quickly institutions need to buy new ones in, which is a problem in terms of manufacturing costs. Beyond this though, servers need to use energy and therefore emit carbon just to store and back up data. fMRIPrepCleanup was built to automatically comb over output from fMRIPrep and delete files that you don't need. I'll cover the actual usage of the script soon, but first a little about how it works. At a basic level, the script takes the directory path as input and then deletes every file inside that doesn't meet certain conditions. This has upsides and downsides. The upside is you can use this script regardless of how your fMRIPrep output is structured. It might be that you have a derivatives folder that contains all the output files for your sample and a separate scratch folder that contains all the working directory files. Alternatively, you might have a single folder for each subject which contains all of their output and working directory files. The downside is that if you point this script at the wrong place, it'll delete a whole load of stuff that has nothing to do with fMRIPrep. You could point it at your home directory and it would just delete everything inside. Or you could point it at a folder that does contain fMRIPrep output, but also contains a bunch of first level analysis files. It'll keep the target fMRIPrep files, but delete everything else generated in analysis. As I'll keep saying, it's therefore very important to check that you've specified the right directory, and to be sure that this directory doesn't contain anything outside of fMRIPrep that you want to keep. With that said, here are the files that are targeted for retention. In every case, any corresponding JSON sidecar file is retained alongside the actual file of interest. First, any files containing the string preproc. This will catch any final preprocessed nifty files in either the inat or func output folders for a given subject. Second, any files containing the string brain_mask. This will be a binary file that corresponds to each preprocessed file that can be used to determine what is and what is not brain tissue. Third, any files containing the string confounds. This will just target the motion confounds file generated for each run for each subject that can be used in subsequent analysis. Fourth, any file containing HTML. This is important because it will retain the final output report for each subject, as well as some of the figures used to generate it. Fifth, by keeping any files with the string SVG, we'll catch the remainder of the figures used for this output report. Finally, any files containing the string emissions. This should just grab one file and only if the user has requested it. By toggling on track carbon in the fMRIPrep command line, you can get a CSV file containing estimated carbon emissions for the pre-processing of each subject. I recommend doing this if you're interested in green computing. See the fMRIPrep usage webpage for more details. Unfortunately, a few unneeded files will still slip through the cracks with these conditions, so the script further deletes any files containing strings index.html or single_subject_ and fsaverage. For the structure of my data, which just contains one run of a single task for each subject, using the default fMRIPrep output space, running with these strings would delete everything in the working directory for a given pipeline and would leave the following output files for each subject. For my purposes, this is enough to run subsequent analysis on my data and double check the quality of it using the summary report. As I'll get onto soon though, there is some flexibility in the files you can request to be kept or deleted depending on your research needs. As I've said, I've just used the default output spaces, but if you were to request extra output spaces in the fMRIPrep command line, The same files will be retained for each run in each space. Now I'll go over the specific usage of the script, covering each of the possible arguments you could pass to the command line. First, the dir argument is used to tell the tool which directory you want to be cleaned up. This should be a valid existing directory that you have access to. The script will let you know if this path doesn't exist. It'll also loop through files in the directory to look for files it would expect to see in an fMRIPrep output folder. This includes folders containing the string sub something to indicate out files for a given subject, that also contain files with the string preproc to indicate the presence of preprocessed files. It'll warn you if it looks like your path doesn't contain these strings and will give you a chance to exit. As I'll keep saying, be very careful when specifying this path. The script should catch cases where you provided a path that doesn't contain fMRIPrep output, but won't be able to point out when the path includes other files that didn't come from fMRIPrep. Personally, the path that I give in this argument is a folder that contains all of the derivatives for a given pipeline, all of my HPC log files generated during preprocessing, and the working directory files for this sample. You could just as easily point it at a path that contains just fMRIPrep derivatives and then manually delete the working directory files yourself, if this better suits the structure of your files. Second, the method argument is used to specify what you actually want to do with this directory. Luckily, you don't have to charge in straight away and delete everything. Using method sim_link will instead create a new folder which will itself contain a retained and a deleted folder. These folders will contain symbolic links to all files that will be retained and deleted respectively. This is a great way to check that the script is doing what you expect it to do to your data. You can use the retained folder to check that you're keeping everything you want to keep, and the deleted folder to check whether anything important outside of fMRIPrep would be deleted, given the directory you've provided. For instance, make sure this simulated deleted folder doesn't contain any first level analysis files. You can then delete files within this directory with more confidence. Using method sim_copy will do the exact same, but instead of creating a new folder with symbolic links, it will create a new folder with copies of all the files that will be retained or deleted. This isn't as ideal since it will involve generating additional files, which will take up more space on your system and will itself have a carbon footprint. However, this might be needed if you're running the script on systems on which sim_link doesn't work. This could be an issue of working outside of Linux, for instance. Once you've used this to check that all looks okay, please do delete your new copy directory to avoid taking up unnecessary storage. By default, the new simulated directories for both of these simulated methods will be placed in a new folder named fMRIPrepCleanup _simulation_ and then either copy or link, depending on what you've gone with. As I'll come on to soon, there is a way to place things in a different directory. In both simulation modes, there's no risk of deleting or moving any files in the original target directory you've provided. Finally, method delete will run the script as intended and will delete non-target files in the directory you provided rather than generating new files, links, or folders. I highly recommend running one of the simulation modes on your data before proceeding with deletion mode. If you want to be extra safe, you can even try running deletion mode on a copy of your data before doing so on the original full directory. Moving on, the also_keep and also_delete arguments are used to change the criteria set for retaining and deleting files. Both arguments take a list of strings separated by a comma with no spaces, like in the format shown here. As covered, the strings now on the screen are the only ones that we'd retain by default. Let's say there's another type of file you want saved that isn't included in this list. For example, maybe I run the optional ICA aroma, which saves output in a file containing the string aroma. I could add in the command line the argument also keep followed by aroma. In this case, any files of aroma in their name will be added to our list of target strings and will not be deleted. On the other hand, there may be files that the script keeps by default that I'm actually not interested in keeping. For example, by default the script will not delete any preprocessed files in any output space. But for my purposes, I have no use for preprocessed structural data in any subject's native space, which are indexed in output using preproc_t1w. I can add the string t1w to my also delete list. In this case, if any files meet the default target criteria but also contain this custom string, they'll be actively deleted rather than retained. These two commands can therefore be used to adapt the files that will be kept or deleted. Again, be careful when specifying extra strings for deletion. Think about whether this choice will have any ramifications for the files that you are interested in. Unlike the others we've covered so far, the also keep and also delete arguments are both optional. You don't need to specify either. The final possible argument is out_path. This one is simple and only applies when you're using either the symlink or symcopy method. Whereas by default, the linked or copied output directory will be created in your current working directory, this argument allows you to provide another file path in which this output should be stored. This file path must be an existing folder. The link to or copy of your data will be placed within it. Again, this argument is optional. You don't need to specify it. Let's look at a couple examples of a full command line in action. In this first example, I'm keeping things as simple as possible. After carefully checking that I've chosen the correct directory and that it doesn't contain any non-fMRIPrep files, I'm going to execute the script on this directory. I'm going to set the method as sim_link to create symbolic links to the files that I'm interested in. In the terminal, I'm instructed on what will happen and asked to confirm that I'm happy to continue. I can then go into the folder that's been generated in my current working directory to check that all looks as it should. All looks okay, so I repeat the above, but this time using the delete method, so files are actually removed from the original directory. Again, I'm warned about what will happen and asked to confirm that it can go ahead. All unneeded files are then tidied up in the directory path I provided. In a slightly more complex example, I'm using the symlink method again on the same directory. This time, I tell the script that I want to also keep any files containing the string aroma and to also delete any files containing T1W. I say that I want the simulated output folder placed within a new directory that I've created specifically for this purpose. The simulated output would be the same as above, but in a different location and taking account of the extra retention and deletion criteria I've given this script. Hopefully this video has given you a clearer idea of how to safely use fMRIPrepCleanup to tidy up your unneeded files. If anything is still a little unclear, please consult the README file on the GitHub page or raise an issue. I'll do my best to address it as soon as possible.